Hello everyone, welcome you all to today's class, and our today's topic is regarding increasing and decreasing functions. And as we have already studied the concept, so today our turn is to solve some questions. And before solving some questions, I would like to share with you some tips and tricks on how to find intervals in which the given function is strictly increasing and strictly decreasing, right? So let's start with the steps. So first step is find f dash x. Second step is find critical points. So critical points means the points at which first derivative equal to 0. It means the points at which f dash x equal to 0. Third step is number line. Here what we are going to do, we will plot the critical points on the number line. Okay, it means if we have two critical points, it will divide the number line into three parts. So each of the parts will be an interval, right? So if in case we have three critical points, then it will divide the number line into four parts. It means we are going to get four intervals there. Last step is getting the table to determine the result. It means writing these intervals in tabular form, and at each interval we have to test whether f dash x is greater than 0 or less than 0, so that we can determine whether the function is strictly increasing or strictly decreasing. So let's get ready to solve some questions. So the first question is fx equal to 3x to the power 4 minus 4x cube minus 12x square plus 5. Find the intervals in which this function is strictly increasing and strictly decreasing. Okay, so this question was there in 2014 CBSE exam. So first step, get f dash x. So here f dash x equal to 12x cube minus 12x square minus 24x, right? So f dash x, after getting f dash x, the next point is, the next step is find the critical points. So before getting the critical points, in case of polynomial function, what we do, we write it in a simpler version. Means 12x can be taken common. So we are getting f dash x equal to 12x into x square minus x minus 2. So here 12x into x minus 2 into x plus 1. It means while getting f dash x, before you get critical points, in case of polynomial functions, if possible, you have to factorize like this. Write as a factor of 2 or 3 terms. Okay. Then second point is find the critical points. So critical points means the point at which f dash x equal to 0. So f dash x equal to 0 implies this is equal to 0, right? It means x equal to 0, x equal to 2 and x equal to minus 1. It means we are getting three critical points. Third one is number line, means plotting these 3 points on the real number line. So let us take the number line like this, right? So minus 1 is the smallest. So minus 1, 0, 2, right? So these 3 points divide the number line into 4 parts. So each part is an interval. So for example, here 2 and 2 onwards. So it means this interval can be taken as 2 infinity. Okay, this interval can be taken as 0, 2. This interval can be taken as minus 1, 0. And this interval can be taken as minus infinity, minus 1. Okay, and please observe, I have taken open intervals because we have to get the intervals in which function is strictly increasing and strictly decreasing. For strictly increasing, f dash x has to be greater than 0. Similarly, for strictly decreasing, f dash x should be less than 0. So nowhere we have to take f dash x equal to 0. And at x equal to 0, 2 and minus 1, f dash x equal to 0. So we cannot take x equal to 0, 2 and minus 1, right? So it means we have to take the open intervals. Is it clear? So next step is table to determine the intervals, table to determine the result. Okay, so let's take the next step, last step. So step number 4, the table, you have to draw the table like this, intervals, sign of. We have 3 factors here, right? So x minus 2, x plus 1, sign of x minus 2, x plus 1, then sign of f dash x, then result. Okay, so first I have taken the intervals from this side. First interval is to infinity. It means x is greater than 2, right? So you can imagine a number which is greater than 2. So maybe it is equal to 3, right? So 2, between this interval you can take x equal to 3. So it is positive 3 minus 2 positive, 3 plus 1 positive. Now positive into positive into positive. So here it is positive. So you can write here strictly increasing. Then 0, 2, interval 0, 2. So you can imagine a number, you can think of a number between 0, 2. Such number may be x equal to 1. So positive 1 minus 2 negative, 1 plus 1 positive. Now product of 3 terms, positive into positive, negative, strictly decreasing. Next, minus 1, 0. Okay, so think of a number which is more than minus 1, less than 0. Right? So maybe you can take minus 0.5. So minus 0.5, negative. Here it is minus 0.5 minus 2, negative. Then minus 0.5 plus 1 positive. So here negative into positive. Okay, so you can take here, this will be positive. So you are getting here strictly increasing. Now last one is between minus infinity minus 1. It means any number less than minus 1. So maybe you can take minus 2. So if it is minus 2, negative, then here it is negative, this is also negative. So you are getting negative, strictly decreasing. So now the conclusion is, fx is strictly increasing on, so here it is increasing and here it is increasing, to infinity union minus 1, 0 and strictly decreasing on, so this 0 to union minus infinity minus 1. Okay, so this is the steps of solving the questions, right? So I hope you understood this. We will take one more question. So next question is, fx equal to x plus 3 whole cube into x minus 3 whole cube. Okay, so here it is x plus 1. Okay, x plus 1 whole cube into x minus 3 whole cube. So step 1 is, we have to find f dash x. So here the question is, find the intervals in which fx equal to x plus 1 whole cube into x minus 3 whole cube is strictly increasing, strictly decreasing. Okay, so fx equal to this. First step is find f dash x. So f dash x equal to, you can apply product rule here. right? Product to learn chain rule. So 3 into x plus 1 whole square into 1 x minus 3 whole cube plus 3 into x minus 3 whole square into 1 into x plus 1 whole cube. So it means you are getting here 3 into x plus 1 whole square x minus 3 whole square. So taking 3 into x plus 1 whole square into x minus 3 whole square, you are getting x minus 3 here plus x plus 1 here. It means 3 into x plus 1 whole square x minus 3 whole square into 2x minus 2. It means 6 into x plus 1 whole square into x minus 3 whole square into x minus 1. Okay, the question is we have to find intervals in which fx is strictly increasing and strictly decreasing. Means f dash x greater than 0, f dash x less than 0. We have to find the intervals. Right? So next step is after getting f dash x, critical points. F dash x equal to 0 implies x equal to minus 1, 3, 1. So we have three critical points, x equal to minus 1, x equal to 3, x equal to 1. So next step is at the number line. So here three critical points, one is minus 1, so here it is minus 1, then 1, then 3. So it means we are having four intervals. One is towards this, then it means 3 and more, between 1 and 3, between minus 1 and 1, and to the left of minus 1. Right? So it means this is your 3 infinity, 1 3, minus 1 1, and minus infinity minus 1. Okay, so these are the four intervals. Okay, so next step is getting the table. So while getting the table, so you have this format, intervals, then sign of x plus 1 whole square, x minus 3 whole square, x minus 1, then we can get f dash x. So we have the intervals 3 infinity, 1 3, minus 1 1, minus infinity minus 1. Okay, so let's think of a number which is more than 3. Suppose for example it is 4. So here see I have written x plus 1 whole square into x minus 3. Being perfect square, it will always be non-negative, right? So that's why I have written this column, I mean it is one column, right? Then x minus 1. So here you see, if you take x equal to 4, which is more than 3, so it is greater than 0, right? So it is positive, and 4 minus 1 also positive. F dash x positive, it means you are getting here strictly increasing. So next 1 3, the number which is more than 1 less than 3, so maybe you can consider 2. So 2 plus 1 whole square greater than 0, 2 minus 3 whole square greater than 0, so it is positive. Now 2 minus 1, it is positive. So it means f dash x positive. So here it is strictly increasing. Minus 1 1. So between minus 1 1, so you can think of a number. So maybe you can take 0. So 0 plus 1 whole square, 0 minus 3 whole square. Positive, 0 minus 1, negative. So here negative, strictly decreasing. Last one is between minus infinity minus 1. Means you can take less than minus 1. So maybe you can consider minus 2. So minus 2 plus 1 whole square, minus 1 minus 3, minus 2 minus 3 whole square. This is positive. Now here minus 2 minus 1 negative. Okay, so you are getting negative, strictly decreasing, right? So in normal case, you get alternately plus minus, right? But here you see the deviation, I mean plus minus. So it means fx is strictly increasing on this union this. So if you observe, it is 3 to infinity, right? 1 to 3. It means 1 to 3, 3 to infinity. So if you combine these two intervals, it will be 1 to infinity except 3, because 3 is not included, right? So you may write here 1, you can write here 1 to infinity, 1 to infinity except 3. Okay, similarly, strictly decreasing minus 1 to 1, minus infinity to minus 1. It means if you combine these two, it is minus infinity to minus 1 union minus 1 to 1. So, minus infinity to 1 except minus 1. Okay, so you can write here minus infinity to minus infinity to, yes, minus infinity to 1 except minus 1. Okay, so basically strictly increasing like this, or you may write also 3 infinity union 1 3, then minus 1 1 union minus infinity minus 1. Okay, so writing like this or writing like this, it is same thing. Okay, so basically the polynomial functions you can try like this. So next question is trigonometric function. So here I have taken fx equal to sin 3x minus cos 3x. Find the intervals in which this function, where x belongs to open interval 0 pi, is strictly increasing and strictly decreasing. Okay, so step 1 is find f dash x. So here f dash x equal to 3 cos 3x minus of minus 3 sin 3x. Means we are getting here 3 cos 3x plus 3 sin 3x. Second step is find a critical points. Means f dash x 0, right? So f dash x equal to 0 implies 3 cos 3x plus 3 sin 3x equals to 0. It means 3 cos 3x equals to minus of 3 sin 3x. Dividing both sides by cos 3x. So you can have 1 equal to minus tan 3x, or you can say tan 3x equal to minus 1. So as you know, whenever tan 3x minus 1 can be written as minus tan pi by 4, right? But we have the restriction x belongs to 0 pi. It means we cannot write here tan minus pi by 4. We cannot take the value less than 0, right? And also x belongs to 0 pi. So here we have 3x. It means we have to take, if you go to the quadrant system, so here you see tan theta is negative here and here, second and fourth quadrant, right? So minus tan pi by 4 can be written as tan pi minus pi by 4 means angle in second quadrant. Or you may write tan 2 pi minus pi by 4 angle in fourth quadrant. Or you can take tan 3 pi minus pi by 4 which is 11 pi by 4. Why 3 pi? Because see, when x belongs to 0 pi, it means 0 less than x less than pi. So 3x is between 0 and 3 pi. Here you see we are taking angle for 3x. Okay, here angle 3x. So the range of 3x would be from, between 0 and 3 pi. That's why we are taking here second quadrant means this one pi minus pi by 4. Fourth quadrant is here 2 pi minus pi by 4. Again we are going like this. Here again we are having 3 pi minus pi by 4. Okay, so you are having 3 critical points now. So it means 3x equal to this. So you can have 3x equal to 3 pi by 4, 7 pi by 4, 11 pi by 4. Or you can say x equal to pi by 4, 7 pi by 12, 11 pi by 12. Okay, 3 critical points. And you can observe pi by 4, 7 pi by 4, 12 and 11 pi by 12. All 3 values are between 0 and pi. Right? So, next step is getting the number line. Okay, so now you see, because we have the restriction, we have fixed interval here. So what you can say, you can take 0 here and pi here, right? The first one is, so pi by 4, 7 pi by 12 and 11 pi by 12. So you have to plot on the number line, right? So after getting this, pi by 4, 7 pi by 12, 11 pi by 12 between 0 and pi. So you can observe here, we are getting 1, 2, 3, 4 intervals, right? So one interval is 11 pi by 12 to pi. Next 7 pi by 12 to 11 pi by 12. Here pi by 4 to 7 pi by 12 and 0 to pi by 4. Okay, so I have written these intervals. So we have to check, right? Unlike your polynomial function where we used to have the factors, here we do not have such thing. So I have added one column here. Instead of checking at each factor, because we do not have the factor, I have added here test point so that we can calculate easily, right? So 0 to pi by 4. Think of any point between 0 and pi by 4. So between 0 and 45 degree, you can take 30 degree, means pi by 6. So if I take the test point as x equal to pi by 6. Okay, now let's check sine of f dash x. F dash x is this one, 3 cos 3x plus 3 sine 3x. When x pi by 6, this will be pi by 2. So cos pi by 2 0, then 3 into sine pi by 2. Sine pi by 2 is 1. So it means you are getting x equal to pi by 6 means f dash x is equal to 3. Okay, check on this. If you want, you can write here also f dash x equal to 3. Right? It means sine of f dash x is positive. So result is strictly increasing. The next one is pi by 4, 7 pi by 12. So now think of a point which is more than pi by 4 and less than 7 pi by 12. So such value, so I think it will be pi by 3, 60 degree, right? So if you write here x equal to pi by 3. Okay, now check for f dash x. So writing this is optional, right? You may calculate in rough and you may not write down this. So here just to show you I have written. So f dash x, so x equal to pi by 3. 3x will be pi. Sin pi 0, cos pi minus 1. Means you are getting here minus 3. So you are getting minus 3. It means f dash x is negative. So it is strictly decreasing. Third one is between 7 pi by 12 and 11 pi by 12. So maybe you can think of some value which is more than 7 pi by 12 and less than 11 pi by 12. So can we think of such value as 2 pi by 3? Yes. So looking at the quadrant you can find also x equal to 2 pi by 3. So now you see what will be f dash x. If you take 2 pi by 3, so cos 3x, it means cos 2 pi. Cos 2 pi equal to cos 0, that is equal to 1. Right? So here 3 sin 2 pi equal to sin 2 pi equal to sin 0, that is equal to 0. So this is 0 and this is what? Cos 2 pi equal to 1. So it means you are getting here 3. So which is positive, strictly increasing. Okay. Now your last point is, so between 11 pi by 12 and pi, you can think of a value which may be like 17 pi by 18. Because we are here in second quadrant. I mean like this. Okay, after one complete rotation we are going here. So that's why 17 pi by 8. Now we need to calculate this. Whenever you take 17 pi by 18, 17 pi by 18, so your 3x would be 17 pi by 6. So you are having f dash x equal to 3 cos 17 pi by 6 plus 3 sin 17 pi by 6. So here to write 17 pi by 6 you may take it as 3 pi minus pi by 6. Right? So 3 times cos 3 pi minus pi by 6 plus 3 sin 3 pi minus pi by 6. So as you know, so 3 pi means you are here. 3 pi minus theta means you are in second quadrant. Okay, so 3 pi, so 0, pi, 2 pi, 3 pi. So 3 pi minus theta means it is in the second quadrant. Now in second quadrant, cosine is negative, sine is positive. Right? So when you write cos 3 pi minus pi by 6, it is minus cos pi by 6. So it means minus 3 into cos pi by 6 plus 3 sin pi by 6. Cos pi by 6 is root 3 by 2. Sin pi by 6 is 1 by 2. So we are having minus 3 root 3 by 2 plus 3 by 2. Taking 3 by 2 common, we are having 1 minus root 3. And 1 minus root 3 is negative. So you are having here f dash x negative. It means strictly decreasing. Now the conclusion is fx is strictly increasing. You will write down here fx is strictly increasing. Yeah, so fx is strictly increasing on 0 pi by 4, 0 pi by 4 union 7 pi by 12, 7 pi by 12, 11 pi by 12 and strictly decreasing on pi by 4, 7 pi by 12 union 11 pi by 12 pi. Okay, so this question is a very good question. You may expect such questions in, so at least in 4 marks, right? So this was in the CBSE Delhi 2016. It has already come. Okay, so in that way, from that point of view, it is important for CBSE exam also. So in today's class, we have taken 3 questions, right, and some tips and tricks. So I'm sure these tips and tricks, the tricks will help you to solve the questions, right? And also we have taken 2 functions which are polynomial functions, and one question like this which is based on trigonometric functions, right? So thank you so much, and I am sure you will be practicing this, and this class will be really helpful to you. Okay, so maybe in the next class we will be coming up with some good questions, like questions based on increasing decreasing functions, and also functions involving logarithmic functions and some more trigonometric functions. So thank you once again, and see you next in the next class.